the eatable, what is not eatable. So then adjust in his brain. So if that one is the lid is open, then we cannot eat. Not always. So back and forth, back and forth. We try to lose the error, okay, which is called the later loss function. We try to minimize the error until the not change it. So at the time, back and forth, back and forth, back and forth, which is called the epoch or iteration. We need to keep doing a lot. And also at the same time, so as you can see from the sample data set during the presentation, the one team has the 10 attribute. One team has the 8 attribute, like that. But what about the natural language processing, 1 to 8? How many features? 100,000, sometimes almost millions of the feature. That will be used for the classification. From the data structure point of view, the size of dimension of the such a data is huge. So we need to do the huge computation. So because of that, the conventional approach is called the shallow learning. So it's a conventional approach. Or, however, on the other hand, the neural network-based approach is a huge computation. Is deep. The deep means it's a huge iteration and with the high dimensional data. That's called the deep learning. Deep learning from the both the classification problem nowadays and also unsupervised learning clustering. So in this class we will cover this week, next week, and next week the classification problem. From the classification approach like the decision tree, Bayesian approach, and the neural network, the artificial neural network, and so on, and the clustering, K-means algorithm. Couple of teams mentioned about the K-means and the other the clustering algorithm, and the deep learning part. We do not have enough time to cover each and every deep learning. Every day the new approach is coming out. We will mostly cover the CNN, the convolutional neural network, RNN, recurrent neural network, and LSTM, long short-term memory. I think pretty much if we have a time, I'd like to introduce the GAN. Also, GAN is one of the most popular the deep learning approach nowadays. But you can get more details and practice and information from the deep learning class. But in this class, we will discuss the basic, the deep learning approach. These are the overview of the data mining, the technique in terms of the machine learning. Okay. So today we are going to start with the classification problem. So this is a summary of the supervised learning and unsupervised learning. Okay. Sometimes this class is called the label. Okay. So it has the labeled data, but the clustering does not need the labeled data. And also data set. Most of the classification problem use both training data set and testing data set. So training is for parameter tuning or creating the model. So it is used for training. Testing means we don't know whether this training is okay or whether we need to stop or not. We need to evaluate. For the evaluation, we can use the tested data set. Okay? So most of them divide into one is a training, another one is a testing data set. Okay? At that time, you know what is the true, what is the false. You know the result. That is called the ground truth. So when you select the data set, you need to check whether they provide a class. whether your problem, your problem has the true or not. So that is called the ground truth. For example, if you collect like the coronavirus, you predict, but the WHO does not release any result, then how do you evaluate whether my algorithm is correct or not? We don't know. What if the Chinese government released the fake data? No way. So that is the reason that when you collect the new data set, you should be careful. Sometimes you need the help of expertise. Like a lot of data sets are related to the healthcare, whether cancer or not. Who decides the cancer? Medical doctor. So you need to pay a lot. It's very expensive. So that is the reason I ask you to find the data set from the Kaggle or such a the well-known the repository or archive. So to get the labeled data or class data or training and the test data with the ground truth. On the other hand, the clustering does not need the specific class. However, still you should know whether this one belongs to group 1 or not, group 2 or not. Then we can use this kind of cluster for prediction also, which is called the outlier detection and so on. If we have the new data here, so we can judge it. This one belongs to class 1 like that. At the time, you still need the ground truth. Sometimes yes, sometimes not. So that is the supervised learning and unsupervised learning. Okay. We talk about the very important terminology. One more time. So you should know what is a class, what is a label, and what is a supervised, and the unsupervised, and the training and test. One more thing is later you need to judge how much accurate the implementation algorithm is, which is called evaluation. So evaluation is the last step of the data mining. So if the approach is not good enough, go back to the beginning and optimize your algorithm. Then until you achieve the goal of the target of evaluation. For the evaluation, there are several techniques. So pretty much next week we will talk about the more details, the evaluation. Okay. Not just the accuracy. So accuracy cannot show the really how much good your algorithm is. So we need to think about the several different approach, the metric for the evaluation. So in your project, you need to also think about how to evaluate your algorithm is. Whether you have the ground truth. If you have the labeled data, it's simple. Not simple, but much easier. If you do not have labeled data, like the coronavirus, what if we do not have such a result? So you need to think about. At the time, there are different ways, alternative way to evaluate, but that is one key factor when you are doing. So first we are going to see the classification problem that can be used for prediction later. Okay. So after we train, then we test, evaluate, we have model. Okay? So if we have new data in, then we can predict. Okay? Whether this is the cat, this is dog, this is animal, this is a human, and this is a wildfire, this is the good host or bad host, we can predict. Okay? So in other words, the classification is called the model construction. So as I said, this part, the data structure that keeps the experience, okay, or frequency, that is called the model. So you can build a model. Then based on the created model, you can apply to the new data set, okay, with the specific accuracy. This is an example of the data. I don't like this data set, but this is a data set for the tenured or non-tenured the faculty. Tenure is very important for the faculty. Tenure means there's no retirement. So even though I do not teach here, even though I don't do anything, so you cannot fire me. So that's the tenure system in US. Only few jobs has such a tenure system. One of them is a professor. But anyway, so to be tenured is very tough. So sometimes the people, the professor, researcher, they try to predict whether it can be tenured or not. So this is kind of one of the examples. So we have data. So data, in data mining, we call the item. Or in terms of machine learning, it's called, do you remember, feature. So we have the features, how many features? Name, rank, year. Then tenured is the class, labeled class. So we'd like to know this one. In your problem, you need to decide this kind of class label. That's the problem definition in terms of data structure. So these are the given. We'd like to eventually predict this one. So we have a labeled data set. So using this experience, we'd like to build a model. In other words, it's called a classifier. Because of the name classification, it's called a classifier. So when you read the technical paper or for the reading assignment or the other technical paper textbook, you will see this classifier is better than the other, and you can build a classifier, ABC classifier. Classifier means model. What data structure, what parameter, it's the same meaning. So our goal is to create such a classifier. So in the project, eventually, the final goal is to create your own model that solves your problem. Okay? Then this is an example. It's a rule-based one. Old, but it's easy to interpret. If rank is a professor and the number of experience, the number of years of experience is higher than 6, then tenured is yes, like that. So can we get such the model? So how? That is the data mining algorithm. So then if we have such a rule tester, if we have new data like the professor level, name will not be used, right? So professor level and 5 years of experience is or, so it's a tenure. So we can test it. So that is the classification. Then problem is how. So in this class, I would like to mostly talk about the two approaches. One is the decision tree, another one is the Bayesian, the naive Bayesian, the classifier. So, but if we have a time, we can cover up to the naive Bayesian, otherwise the decision tree and a little bit about the evaluation. So, okay, these are the data. The problem is this is I think the one team is the product demand. As the project topic is kind of similar, different. So in the PC, the retail shop, they try to predict whether the customer buy a computer or not. Okay, so they have the number of data item or number of features. Okay, then each data item has age, income, student, and credit rating. This is the what? Labeled class. We try to predict this class label, okay, whether buy or not. So we have such a data. So our goal, first approach is the decision tree. So decision tree is still being used. The simple and it provides a reasonable result and very fast. So because of the still being used, and also it provides the intuitive idea, impression of the data mining technique. So, from the given data set, we try to build a kind of a rule, like the decision tree. So, let me ask you questions. When you talk about the information, there are important information. There are useless information. So I'm going to give the two information you are going to decide. The next week, I'm going to have a lecture. Okay? That's the A information. Then another information that I'm going to give you is the next week, those who are studying the neural network and artificial intelligence and write the 100-page the summary, I will give the A+ grade. Which one is important? A or B? Second, definitely B. Then why B is important?
You're expecting an output.
Expecting output?
Yeah.
Did you expect the
No.
B information?
Because
No.
A is repeating since many days.
A is a user.
Yeah.
User means it's
Obvious.
it's not very interesting. It's a happen normal. The B is unusual. No professor asks such a thing, and also offer the A+ grade, final grade. It's rarely happen, but this one is important. So if you measure the information, amount of information, which one is higher? B or A? Definitely B is higher. So when we talk about the information, so we try to measure such information. At that time, how can we measure the importance? How much? Where? If something happens, the usually normal information, it's not very important. We don't care. However, it's rarely happen, rarely suggest the offer the A+ grade. Okay? Every time, no. It's just one in a year, like that. Then, if rarely happen, the information is very important. So it's very high, the value of the information. So we try to use such a information to measure the such a information. We are going to consider probability. So probability, if rarely happen is important. And if normal is frequently happen, it's not important. So among the equation that you learn in algebra, what kind of the equation can represent such a thing? So 0 rarely happen. It's the infinity, frequently happen. And importance is higher and so on. What function? Anyone? Log, but log is like this. So we can use minus log. Okay? Minus log, and also this one is a probability. Probability is 0 to 1. So we don't need this part. So this. So minus log p. So we can use minus log p to measure the information. Then keep this equation in your mind. Then, so we try to select when we classify the by or not. Okay, so such a thing. We try to decide the important attribute, right? When I judge the student, what attribute are the most important? Grade, or the age, or the income? So grade, okay? At that time, which one is better? It's the same question that I asked during the PCA. Which the A and B, which variable is better for data analysis? A is better because it's a stretch out. So we can easily check that this one is different, but this data is the same. It's the same idea in the information, the theory. So which attribute is better? It's the all difference or the all same? If they are all the same value, no way to classify, right? The value should be different. In other words, value it should be what? Rarely happen. Their probability is less and less. So for example, this one is less, this one is less, this one is less. But if something attribute is the all same value, no way to classify, right? So at that time, to measure the difference, we are going to use the entropy. So entropy means it's kind of energy of data. Okay? So think about it. All the values are the same inside. Do you think it's a high entropy, high energy, or low entropy, low energy? They are same. So for example, in this room, all students are identical. Any active? No, it's just exactly same each other. So no argument, nothing. But if everybody is different, every time argue, it's a high energy, high entropy. So we try to select such an attribute. They are different each other. So to represent such a different, we are going to use the entropy. So we try to find the high entropy, the attribute. In other words, this is the impurity. So low means they are identical. It's a purity. So purity means so how much similar each other. If the data are similar, it's not good feature. Instead, if data are all different, rarely happen. High entropy, so that is the good feature. So in first the decision tree, to select the attribute, we are going to use the entropy. From the information theory, we are going to use the entropy. To measure the such a purity or entropy or energy, we are going to use the log the pi. Pi is the probability of the data. Then it should be minus to get such a thing, but it's between the 0 to 1, so we multiply by the pi, so it will be like this curve. So we try to find the feature that has the high entropy, so that represent this one. This is the case of binomial. So two distinct values, but it can be easily applied. They extend to the n number. So our goal is to find the higher entropy, or it's the impurity or higher uncertainty, all different attributes. So how can you find? We try to collect the sum of all entropy for each value. So collect the all entropy, then let's say that we have the 3 feature values. So first feature, we calculate the entropy. And second feature, entropy. Third feature, entropy. Then we try to find the highest entropy. For example, number 1 feature is the highest entropy. We select this feature to classify. Okay? So first, intuitively understand that when we decide buying computer or not, what features are different. Make the difference between the buying or the not buying computer. If all the values are the same, so man, so we cannot use such a thing. But if the age, like the 10, 20, 30, 40 variety, then we are able to classify. So that can be represented by the entropy. So entropy can be calculated as the P times log P. I explained why log to give the highest value, and minus is the opposite, the positive value, and the probability of it. Then sum of all the data, then that represents the purity or entropy or energy, how much different each other. Then to select the by or not by computer. So we need to decide the first attribute for the decision tree. So decision tree, so there are three. First, before 30. Then add up all of this. Then compare with the total amount of the information. Okay? Then similarly, income. We can calculate the income level, the less than the 10,000, bigger than 10,000, 20,000, and 30,000. Then calculate the information, the entropy, sum up. Then we can calculate the entropy of when we divide the data by the income, and so on. Then we can subtract. So highest the difference is the what? It's a high entropy, which means it's a good the attribute to decide, to distribute the data. So that is called the decision tree. It's a really classical the approach, which is called the ID3. So let's see the example. Quickly go over. So our goal is to classify the by computer or not by computer. For the all entropy, we can calculate that here. It's nothing but the P log the P. Okay? And sum of the all of them. It's a buying or not buying computer. Okay? So this is the 0.9 is the total entropy before the partition. Then for age, we can calculate by age. We can separate the group this data by age. Then calculate the entropy sum up. That is a 0.6. And similarly, we can do the income, student, and credit rate. At that time, the most different, highest the difference between the total entropy and this one is the student is the smallest difference. This is the highest entropy, so smallest the difference is the student. So we can select the student as the first group, like that. First, what is the age? Oh, age is the highest one. So smallest difference is the age. So we can build a tree. So by the age, we can build the tree, first level of the tree. Then the next one, we can select, we can apply the same algorithm to decide, except the age, income, student, credit. Then student is the highest, so difference is the lowest one, so student will be used. And so on, until we do not have any more attribute or any more data. Okay? So idea of the ID3 is the decision tree is we try to find the good attribute that can partition. What is a good attribute? That has the highest entropy. Highest entropy means it's impurity. It's the distributed data. Okay? If they are all the same, it's not a good. So we try to find such a high entropy data set. The first one is the age, like this. Then the problem of the ID3 is the more data you have, it's a bias. Okay? If we have a lot of data for the student, it will be the entropy. Entropy is the sigma. It's a summation. So the more data you have, it's the higher entropy, which means it's a bias. So to address that problem, there is a normalized the entropy, which is called the C45, which was the practically used in the market. The C45 is you can see it's divided by the split info is normalized one. So it's normalized entropy. Okay? So we can use the normalized entropy for then finally we have the Gini Index. So Gini Index is you can see instead of the sigma of the P log P, it used the P square. The reason is that sigma P log P is a higher computation. When you have the millions of data, definitely it takes really long time. Because you need to calculate all the sigma for each the subgroup of the data and calculate, so it takes a longer time. So to address that problem, is there any other way to find the good feature? So Gini Index uses the sum of square of the probability, which means if the rarely happen, like the 0.101 is the good feature. So if you square, it's even exaggerate. So 0.001. Sum of such the feature square, then divided by the subtract from 1. In other words, if all the data are the same, which means the P is 1, okay? Probability 1 means it's a normal, identical. So 1 minus 1, so it's a 0. Gini index will be 0 at the time. So Gini index 0 to 1, and also very quickly calculate the purity or impurity. So you can decide easily the feature for the impurity, the data set. So the other idea are the same as the previous one. So we can find the feature. So Gini index also mostly used the decision tree algorithm. It's very fast and so on. So we can calculate the Gini index. So this is a summary of the decision tree. So first we can use the information name. That is the entropy. We can calculate the entropy to decide which one is good feature, good feature, good feature, and so on. Then the gain ratio is the normalized by the size. Then Gini index is we can use the square root instead of sigma to find the feature. There are several problems of the such a decision tree. The first one, we start from the 1, the feature, right? If that is wrong, eventually it's gone. So it's hard to go back. Okay. So overall, is because we are using the index the entropy. Okay. Overall, it looks good, but if that attribute is not correct, it's totally wrong. So and also it's a bias to the data. Even though normalized, it's a bias. Any other way to address that problem? So in machine learning algorithm, there are two hybrid approaches. It's not for, we will go back to this one. In general, there are two hybrid approach. One is ensemble approach. Ensemble means combine. And another one is the bagging. What is a bag? B-A-G. Bagging. Where did you hear about the bag? Relational database. Relational database is a set. Another concept of the opposite concept of the relation was bag. Bag is like for example, relational database allow primary key only, which means it should be identified the primary key, so it has a key. However, bag is just a group of data. It doesn't need the primary key. It's just a put. Okay? Then when you get the data, it's just a randomly select. It's a kind of sampling, not identifying the specific data. So bagging approach is you run again and again and again the same approach, then average. For example, in the decision tree, the one may not be correct. So select the sample data, first time, run result. And from the data set, select the 30% of the random data and run it again. How many times? 100 times. Then average. Maybe better than the one time of decision tree, right? This approach is based on the bagging. So this one is based on sampling. This one is called the random forest. The algorithm. Random forest is very powerful. So their accuracy is higher than you expect. And also, random forest it was not good when we do not have the enough computing power. Because as how many times? 100 times running the same algorithm again and again, but their result is quite better than expected. This is a random forest. Or not, this is a bagging approach. If your algorithm is slow, run it again with a different data set. Run it again, different data set. Then your model is average of them. That is one approach to increase the accuracy. Another one is ensemble approach. Ensemble approach is kind of booster approach. It's most of the problem happen in the machine learning is a bias. It's a bias to the data, bias to the number of data or the size of data. So if you try to reduce such a bias by combining with other algorithm, like the A approach, but we apply A prime approach and combine and A2 prime approach, then your accuracy will be higher. This is a boost approach and also ensemble approach. So these kind of techniques are very popular. So if your algorithm is not working very well, so not better than you expect, you can combine with another approach or run it again with a different data or sampling, then the average. That's the bagging and the boosting. So random forest is kind of the bagging algorithm. So we will see the random forest. So please watch the video. It's a 7-minute video. It explains what is a random forest. What time is it? So 8:05. Let's go straight. If you need to go to the bathroom, feel free to go. Then I will try because we have a lot to finish. Please watch the video to understand the random forest. Random forest is the average of the 100, the many times of the decision tree. You can imagine why random forest. Randomly select the sample data. Then forest means it's a name of our algorithm is a tree. But sometimes it is saying in our the tradition we have the saying that you should see the forest rather than the tree, right? So it's forest is a combination of a lot of tree. So it's called a random forest. I don't think we have enough time for the base classification, which is very important. We will discuss the next part. Instead, I'm not going to explain the rule-based. Rule-based nowadays is not very critical, but one of the easiest way. If you know the data, if you know the rule, you can directly implement the rule-based approach with what? If, then, else. I believe that a lot of students will use the rule-based, hard-coded in your the project B and A. So rule based is not nowadays the very important. Instead, I'm going to skip to the model evaluation. We will talk about the base later. Okay. One more thing. So before we start the model evaluation, you will hear a lot overfitting and underfitting. So when you build your model, our goal is to build a model, right? So to classify, as a classifier, we try to build a model. Overfitting means, let's say we have data like this. So if you apply the regulation model, regulation should be like this, right? This is our expectation. If you too much train, okay, really applied all the parameter and everything, like this, perfect. Do you remember the squared error? Mean squared error or the error root. So you can calculate the error, but this will be 0, right? Perfect. But which one is better, A or B? A is better, right? It's generalized. B is too much trained, okay? It's overfitting. Overfit to the data. This is one of the easy part. It's really happen when you train the model. So you need to avoid such an overfitting. So underfitting is you have the data like this. So our expectation in the linear regression model is like this. So multi-regression model, right? But if underfitting, it will be like this one. Their error is sometimes less than this, but this is too much generalized. Okay, it's too much specialized overfitting. It's too much generalized. That is called the underfitting. So you need to avoid both the underfitting and the overfitting, because our later the deep neural network or the classification algorithm or clustering algorithm focusing on to reduce the error. Okay, so then the error is less, but actually it's too much generalized underfitting. So random forest actually address the overfitting problem. The random forest sometimes has overfitting. The problem too much generalized, too much specialized. Okay, then. So next. Once we have the decision tree or any other model, we need to evaluate. So how to evaluate the data? So we should have labeled data. Label the class. Labeled data or the class, or sometimes it's called the ground truth. So easiest way is true or false. So number of true over number of case is called what? Accuracy. So accuracy is the one of the most popular. I will give the example of this one. So I'm medical doctor, okay? So I'd like to diagnose this corona, the 19, so new corona case. So you are positive, all positive in this room. Am I correct or not? Yes? I don't lose any positive case, right? So which means good. But another doctor, the diagnosis as the all negative, but actually there is only one, the positive case. But the Dr. B said it's all negative. So is it accurate or not? Which one is more accurate? It's very hard to judge in terms of accuracy, right? So to address that problem, so accuracy is actually does not represent really accuracy of the algorithm. We need to consider the positive case, negative case, and their balance. So, for example, most popular approach later, which is called the recall and the precision. So, or there is a precision and recall the evaluation. Also, true positive, true negative, false positive, false the negative. It's a confusion matrix. You need to consider that. So I'd like to introduce such a the validation method and how to validate such a data. Okay. Actually, there are many performance measures. So you can see even a lot. For example, K, L, the D is very popular for distribution in statistics, and TP over FP rate is the precision and recall that I mentioned. Most popular in machine learning, the precision and recall. Accuracy is the very general, but it cannot reflect the really accuracy. And ROC curve is used in the signal processing, very similar as the precision and recall. And something, the measurement metric can be used. So it is also very important to find the proper measurement metric for your algorithm. Even though your algorithm is perfect, because of the wrong decision of the evaluation metric, it can be the overload. Sometimes it can be exaggerated. So people always try to exaggerate, but not to lie. So we will see. So first, the confusion matrix. Confusion matrix is so we are going to use the problem that we have used by computer. So actually I predict, okay? So by computer, this one is the predicted, and this one is the real happen. So real case 7,000 by computer among 10,000, 3,000 not by computer, which means 70% of the customer by computer, 30% not by computer. Okay, so this one is the real case. This one is predict. So my algorithm, so decision tree or whatever, my algorithm 73% by computer. I predict. Okay, that doesn't mean we don't know, because we need to check this one. Whether among the 7,000, 6,954 is accurate. This one is accurate, this is wrong. And this one is also accurate. Among 3,000, we predict 2,588 cases. It's the correct. Okay. At that time, accuracy is false positive. This one is a false positive. This one true positive. So true positive. And T and true negative. Don't be confused. It's really confused. I think that is the reason it's called the confusion matrix. So everybody knows what is the true positive. This one is true means you correct. True means you correct. False means you are wrong. So this one is true positive. You predict the positive case correctly. True negative means you are correct to predict negative case. What about this one? From here, it's really confusing. False, negative, false, you are false. I'm wrong. To predict negative case. It's supposed to be this one, but I predict as a negative. And this one is opposite. It's a false, I'm wrong. For what? Positive case. It's supposed to be this, right? But I predict as a positive. False, positive. So true, false means I'm wrong, I'm correct. True means correct, false means the wrong. Then the positive or negative case. So this is a confusion matrix. What if we have the 3? So in this case, the class is the by or not by 2 class. You have sometimes 3, multiple class. You can build 1, 2, 3, 1, 2, 3. At the time, it's not true positive. It's you correct the class 1. The true, the class 2. True, class 3. Like that. Okay? So you should build a 3 by 3, eventually n by 1 confusion matrix. However, most of case, so it's the 2 by 2 confusion matrix is used. So in this case, accuracy is what is accuracy? So which one will be considered true? I'm the correct. The true case, this one and this one. So for example, the previous case, where is it? Accuracy is 6,954 plus 2,588 over 10,000. This is accuracy. Okay, true positive and true negative over total number. Okay, error rate is the complement of the accuracy, 1 minus. However, the problem is, let's see the cancer diagnosis. So cancer usually 1 over 10,000, for example. Only 1 among 10,000 people. So even though I predict the negative, my accuracy is 99.99. Right? Correct? So if you are not lucky, so you will be cancer and not diagnosed. But I lose only one case. But the medical, such a health science, healthcare, does not allow such a case. Okay? So accuracy cannot reflect the really accuracy of that. We need to consider the importance. Even one case is important. So to address that problem, we can consider sensitivity and specificity. So for the imbalanced data, like the cancer case, so this one is almost a balanced data, like this, 7,000 and 3,000. But the 1 over 10 million, well, 1 over 10,000 is imbalanced data. Imbalanced data, accuracy error rate cannot reflect. Instead, we need to consider how much important the data is. For example, the positive case is 1%. Sensitivity is the true positive over p. So how much? So total, for example, we have the 10 and 9,900. The 90 case. So it's in confusion matrix. So it's a true and the false. And you predict the positive and negative. It's a true positive. So you predict the 9, for example. And this one is 1. And this one is 9,980. This is 9,980 and this is 10, like this. Even though you predict 19 cases as a positive, you get the most of the positive case. Okay? So how much sensitive? 9 over 10. The TP over positive case is pretty much high. So sensitivity does show the importance of the result. So you can show the sensitivity together. And the specificity is the for negative case. So like this one. So 9,980 over it's almost perfect. Okay? So this is the sensitivity and specificity. So the most popular one is the precision and recall. This is the what time? The 5 minutes. Okay, last. So let's among the 100 the student I'd like to classify good student and bad student. So there are 10 good students. Okay? So 1 of 10 good students. So I predict all of them 100 as the good student. In terms of accuracy, what is accuracy? So if you build a confusion matrix, so 10, you have 10, 90. So 100 as a positive and 0, 0. Okay? So 100 over 100. Right? So true positive, I predict the, no. So 10, 90, like this, 10, 90. So it's a 10% accuracy in terms of accuracy. But, so this, when the first record, how many among the positive case I catch? So total how many positive case? 10 case, right? The good student. The record, I get all of them. So in terms of record, it's 100%. Because I correct all 10 good students among 100. Even though 90 wrong, but I catch. This is very important in critical the problem, like the cancer case. I don't want to lose even one case of the true negative, the false positive case. Okay? Actually the positive but wrong prediction. I don't want to do that. So this record, how many positive cases can I catch? 100%. However, I predict how many of them? 100, the positive case. Among them, how many correct? 10. So precision is how much precise my result. How much precise? Only 10% precise. Okay? So we can consider precision and record together for better representation of the accuracy. So this is called the PR, the precision and record. Most of the machine learning can use such a precision and record. In terms of confusion matrix, precision is focusing on one. Both of them TP, true positive case. But the denominator is different. Denominator, if you see for the record, is from we want to get this one from what? The record is this, the really true. In true case, how many of them? So the TP plus FP. TP plus FP is, this is my prediction. Among my prediction, how many of them I get? Record. Okay? Then precision is this. How much precise? Some of them are wrong. If too many, the wrong case, it's not precise, the prediction. So 100% the precision, 100 record is ideal. Okay? But not always that's true. So we try to get the higher record with the higher precision. This one is important, but with the high precision. So that is the precision and record. So by considering both of them, this is the average of the precision and record is the F measure. So you will see a lot of time F measure or the precision and record. So homework. Why don't you calculate understand in your mind the accuracy, precision, record, and F measure based on this example. Next class I will explain one more time this one. Then eventually our goal is to get such a precision and record graph like this. Okay. Next class we will continue the classification with the base algorithm. Then pretty much we can cover the couple of more topics in the classification. If you have any problem on your PyCar, so set up the appointment, then I can help you or the email me.